Oh, hello everyone. Today I thought I'll make a video and walk you through and give you some tips on how to solve manometer problems, problems that you have seen in mass and energy balance too. So shown here is a typical manometer problem where again the goal is to get what is the difference in pressure P1 minus P2. Later on in this transport course, you will see a lot of manometers which are being used to measure pressure distributions and velocities and in a tube of moving fluids. So it's important to reinforce the concepts that you encounter in these manometer problems. Okay, so first before we solve this problem, let me walk you through a couple of important concepts. The first one is Pascal's principle, which states that the pressure at a fluid at rest is the same at all points with the same elevation. So the points A and B, they're going to have the same pressure and they're in the same fluid. Again, shown here is another typical manometer, and just to reinforce the point, this is points 1. So our points 1 will Pascal's principle hold at say the points 1 1. Answer is no, because they are different fluids, they are not connected, right? Same thing with points 2 and 2. Will Pascal's principle hold good? No, it's not the same fluid. I mean, there is another fluid in between, and so Pascal's principle will not hold good. Well, how about 3 and 3? Yes. So you have to be careful as to where you apply the Pascal's principle in when you solve manometer problems. Okay, so that's the first concept that's important. Second one, I've seen a lot of students make a mistake here as well. Pressure increases as one goes deeper into a fluid. Why? Obviously because of gravity, right? So the pressure at B will always be higher than the pressure at A, and for an incompressible fluid, PB is PA plus rho GH, right? Where rho is the density and G is the acceleration due to gravity. So keep this in mind, right? Because I've seen a lot of students make this mistake when they solve manometer problems. Okay, so now what are the steps that you can follow? The first is the most important step. Identify the points where the pressures are equal. Use the Pascal's principle. Step 2, identify the path from one point to another. We will, I'll explain this more when we just work on this problem. And 3, work out how the pressure changes along the path. Keep in mind, as one goes deeper into a fluid, the pressure increases, right? Okay, so again, here is a problem again, the manometer problem where you are asked to find P1 minus P2. First step, identify the points where the pressures can be equal. And again, I've noted it down here on this figure where points 3 and points 4 have the same pressure. So that's step 1. Step 2 is to get the path. So I need to go from 1 to 2, and the path that I'm going to take is, I'm going to go from 1 to 3, and then since 3 and 4 are the same pressure, I'm going to go from 3 to 4, and then I'm going to go from 4 to 5, and then 5 to 2, right? So that's the path I'm going to take. And step 1 has helped me because I know that 3 and 4 are at the same pressure, right? So now work out how the pressure changes. So I start at 1, so I have P1, and then I go from 1 to 3, and 1 to 3, as I go down deeper into a fluid, the pressure increases, so it's a plus. And how much does the pressure increase by? Rho GH, rho G times H1 plus H2. Now I go from 3 to 4, the pressures are the same. Now I go up from 4 to 5, so the pressure decreases. And how much does it decrease by? Rho C times G times H2. Now I go from 5 to 2, again the pressure decreases as I go up. How much does it decrease by? Rho B times G times H1. And now I'm at 2, hence this whole quantity is equal to P2. And that's it, really simple. Now I have the expression for P1 minus P2. So manometer problems are really simple to solve. All you need to do is just carefully identify where the pressures are equal, work out the path, and go from say point 1 to point 2. And I call this a jump technique. I'm sure you're going to find this in a number of different textbooks as well. So